Hello, this is a question from the NZQA, NCEA 2025 Algebra. Started the right level there, level 2. Oh, wanting to put L's everywhere. Level 2 examination, it's question 3B. And I looked at it yesterday and have a video up of the entire examination, and I was being critical of the word "the" in the question, which suggests that there is only one solution, when in fact for this question there are multiple solutions. And then just thinking about it overnight, even though multiple solutions isn't something that's taught at this level, I think it's understandable for a level 2 student to see how there are multiple solutions. And so I thought I'd work through and show how you can get the multiple solutions. In fact, you can get a characterization of all of the solutions. So I did say yesterday you can find values A, B, and C by putting in these two values here. And the problem is that there's three things we need to determine, and two values is typically not going to be enough for us to determine three unknowns. So, but let's see how far we can get. So if we put in x equals 1/5, we get a times 1/5 squared plus b times 1/5 plus c equals 0. And then if we multiply through by 25, so this will be 1 over 25, so that'll make it just a here. This is b over 5, so it'll be 5b, and plus 25c will be 0. And then if we put x equal to minus 2/3, we will get something similar, a times minus 2/3 squared plus b times minus 2/3 plus c also has to equal 0. This time we multiply by 9, 3 squared. That will get rid of this denominator, and negative 2 squared is 4, so we get 4a. 9 over 3 is 3, times the 2 that's already on the top is 6. It's got a minus sign, so actually it's not plus, it's negative 6. I think I might have made that mistake yesterday as well. I had to rub it out, not a serious mistake. And then multiply by 9, you get 9c equals 0. And so now we've got two equations, but in three unknowns. But if we just try and solve these using the standard methods of elimination, what you can get, you can eliminate at least one of the variables from one of these equations. So if we take this second equation and subtract 4 lots of the first equation, so 4 lots of the first equation is going to be 4a plus 20b plus 100c equals 0. This is what we're doing, but in here we've got just the 4 lots of 1, just this bit here we've written down here. And then if we do a subtraction, we're going to eliminate the a. So minus 6 take away 20 is minus 26b. 9 take away 100 is minus 91c equals 0. If you know your 13 times tables well, you can divide both of these by 13. Let's divide by negative 13 to get rid of the negative sign. So 2 13s are 26 and 7 13s are 91. So, and we'll call that equation 3. And then if we use this equation that we've just obtained and this equation here, we can eliminate the b's out of this top equation up here. So let's go down the side. So if we multiply equation 1 by 2 lots of equation 1, and then subtract off 5 lots of equation 2, what you get is you get 2a plus 10b plus 50c equals 0, and down here 5 lots of this is going to be 10b plus 35c equals 0, and we do a subtraction again. We're left with 2a there. The b's will eliminate, and plus 15c equals 0. So now equations 3 and 4 effectively tell us what a is and what b is in terms of c. So we can rearrange these from 4. First, we can get a is equal to minus 15c divided by 2. And from 3, we can get b is equal to minus 7c divided by 2. And as I say, none of this is outside the algebra that you know at level 2, but nevertheless it's not something that's typically taught to be able to solve for 3 variables and from 2 equations. But what the question wants us to have, this would actually be enough to solve these equations if we didn't have this condition that we needed integers for a, b, and c. What we could do here is we call c a free variable, and if you choose a value for c, you can just plug in these two, put the value in these two formulas, and you'll find what a has to be. The question we've got here wants these things to be integers. That's a, b, and c. If we just choose c as an integer, it will be an integer, so that's no problem. To guarantee that a and b are both integers, you'll notice that they've got something multiplied by c and then divided by 2, and the something is not divisible by 2. Therefore, the only way to get integers out of these two equations is to make c divisible by 2. So we want integers, so for any c, that is divisible by 2, we will get integer solutions. Reverting to my very, very poor handwriting. Well, probably not technically writing. Integer solutions. Perhaps except c equal to 0. But any other c that's divisible by 2 will give us integer solutions. If it's divisible by 2, then it's an integer, and if it's divisible by 2, it'll cancel out here, and we'll get an integer for a and b. So therefore, let's say c equals 2n. N is an integer. Normally, integer is denoted by this z symbol, and n is not equal to 0. Then a equals minus 15 times 2n over 2. The 2's cancel, as I indicated, so minus 15n. b equals minus 7 times 2n over 2. 2's cancel, so minus 7n. And yeah, and c is equal to 2n. So we just choose any n that's an integer, not 0, and we'll have a set of values that will give us a quadratic equation. So our quadratic equation is minus 15n times x squared minus 7 times n times x plus 2n equals 0. That represents all integer solutions. So anyway, hopefully that's interesting, if not useful. I don't think anything like this is intended at level 2 in the examination. All of the mathematics in here, though, is accessible to a student with level 2 capabilities. And it just shows that there are an infinite number of solutions. So there's an infinite number of solutions. Every single integer n will give a different solution here. As I say, we don't want n to be 0. If n's 0, then we've got 0 for all of the coefficients, and we don't really have a quadratic. There's a sense in which you might say, well, it is some sort of degenerate quadratic. It's equally valid just to exclude 0 and not have that problem. Every other value of n gives a real quadratic. Real being probably about an actual quadratic. So anyway, hopefully that's interesting and educational, and you get some benefit from seeing that. See you next time.